I got to work in Jerry's classroom all summer, and as an engineer, he's incredibly self-driven and motivated. And if he puts his head down, you can be pretty sure whatever he's working on will be done. And I remember a few times early on in the program, I would come by, check on his progress, and find there were maybe a few errors, and figure that he had a few days of work ahead of him, maybe before the project moved again. And I would come back maybe an hour, maybe two later, and you'd be doing something completely off topic, and I'd be like, Jerry, what are you doing? You know, goofing off, like you have a bunch of problems to fix. And he would give me a thumbs up and be like, they're done. And I think that really encapsulated the experience this whole summer. And his project was absolutely impressive by the time that it was finished, and I hope you'll enjoy it.
Hello everyone, my name is Jerry Gao, and I'm an incoming sophomore at Limerick High School. This summer, my project was a gesture-controlled robot, and what this is that it's a robotic car where the user has a controller attached to their hand, and through hand motions, they can control the movements of the car. And I chose this project because I was really interested in how I could remotely control a car, and I'll go over a few key components on the controller. So I have this MPU 6050 sensor, and has a built-in gyroscope and accelerometer, which measures tilt and acceleration in the X, Y, and Z directions. And I have this Arduino Nano, which reads this data and sends it wirelessly to the Arduino Uno, which is connected to the car. And this is all over Bluetooth, so I have these two H205 Bluetooth modules. One of them is right here, and there's another one on the car. And once the Arduino Uno receives the data, it processes it and converts it into commands for the motor driver to control the speed and direction of the motors. So now I'll go over the demonstration. I have this Velcro strap underneath. It can be adjustable based on your hand size. So you give it a few seconds to connect, and once I tilt my hand forward, it goes forward. Once I bring it back to a level position, it stops. If I tilt it backwards, it goes backwards. If I tilt to the left, it goes left. If I tilt to the right, it turns right. And if I drive straight forward, yep, as you see, my hand is still tilted, but the car won't go forward. And this is because of the 3 ultrasonic sensors I added on the front. So aside from the base project, I did make a few modifications. So the first modification I made was the frame on the outside. It's this white frame going around the entire thing. I 3D printed this and designed it on an application called OnShape. And the purpose of this is to secure all the components inside and to make sure that when I'm driving and turning, none of them will slide around and fall out. And the second modification I made, as I showed you all during the demonstration, is the 3 ultrasonic sensors on the front. These 3 make sure that when I'm driving forward, it won't crash into any obstacles. So even though that the process of putting everything together, designing the entire project, it all went pretty smoothly, I did run into some challenges. So first, it was regarding the ultrasonic sensors. So originally, I only planned on using one of them, but I quickly learned that the field of vision wasn't really spread out enough. So say I have an obstacle over here, this sensor won't be able to detect it. So if I'm driving like this, it's going to crash. So I added 2 more on the sides, and they are angled a bit to increase the field of vision. After this, I still did have another problem with the sensors though. Sometimes they would produce incorrect values. So let's say my car's pointed like this. There's no object within at least 10 feet, but it would sometimes drive and stop because the ultrasonic sensors will produce false values. And to solve this, I fixed my code to, instead of taking every single distance reading, I would find the average of the previous 5 readings. And this would smooth out the false value. So that fixed that problem. And another problem I had, it was actually just a few days before this presentation. I hadn't touched a lot of the motors in a really long time because I was working on the frame and the ultrasonic sensors. And when I tried to put everything together, the motors didn't spin. So I had to do a lot of debugging. I had to make sure the Arduino wasn't broken, the motor driver wasn't broken. I had to make sure I didn't actually delete some part of the code when I was working on other parts. I had to make sure all my connections were sturdy, they weren't loose or anything. But in the end, I realized that the problem was with the voltage. So all along, I've been supplying the motor driver with 6 volts, which is equivalent to 4 AA batteries. And now, as you all see, I'm using 5, and this is sufficient. So throughout my time at BlueStem, I learned a lot of concepts. Just to name a few, I know how breadboard works now. I know how to code using Arduino IDE, which is the application where we code the Arduino. I know how a voltage divider works, and I know the basics of 3D design. But I feel like the biggest takeaway from this camp for me was the confidence in my ability to go online, find an idea, find a project, and actually bring it to life. Because all the materials on my project, they aren't really expensive, they're very accessible, you can find them online very easily. And just taking an idea and turning it into reality, the feeling is like really rewarding. And finally, if I had more time, I would make a few more modifications. As you can see, there's a lot of wiring that's exposed, so I would 3D design another part to hide everything on top. Currently, I have this thing, but as you can see, it's still not really presentable. And another modification I would add is that after I have the top frame, I would put a robotic arm on top. Because to be honest, as of now, my car doesn't really have any practical use in the real world. All it does is drive and turn. It's like a toy RC car. So if I have a robotic arm on top, it can be really helpful to people who can't really move that much. For example, the elderly or some hospital patients. And yeah, that's my demo night presentation. I hope you all enjoyed it, and thank you for listening. Any questions?
So you mentioned that you'd want to connect the robotic arm. How would you connect that in terms of sensors that you have and the robotic arm's motion? Like, what would be the tie-in between the two?
So I would probably have like a separate Arduino. I would probably add another section on the controller. It would probably also be with the 2 H205 Bluetooth modules, so 2 additional ones, because everything has to be like Bluetooth. Any other questions?
What was the most challenging part about working with 2 Bluetooth monitors, just Bluetooth in general?
So the hardest part about that was actually like pairing the 2 together. I had to look up a lot of tutorials because there's like a specific way you pair the 2. You have to go to the Arduino IDE and go to the serial monitor. And you have to like put all these really complicated syntax commands in it. And that's like, you have to like have to be very specific.